Hi guys, so today's video, hopefully you can hear me, so hopefully I fixed that issue, is going to be the page that we're going to put in our interactive notebook on Monday, or, well, if you're in my second period class, we already glued it in and you're just completing it. So we're going to try and see how this works. So this is going to be some translations practice that you're going to do at home, and I'm just going to go over it with you. So thank you for joining me. So let's look at the first one. So we're given this shape. This is going to be our pre-image. So let's highlight it. I don't know how well you can see that. There we go. There's my pre-image. And I need to do a translation of x minus 1, y plus 3. Now we're going to talk about the directions that puts us in just a minute, but I want to get the original coordinates. So I'm going to go to my graph and put the numbers. So here's 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, and then 1, 2, 3. So I just put the numbers on the graph. That way it's easier for you guys to see what the coordinates are. Okay, so I went all the way down to negative 4 and negative 5 on the left and the bottom, and then to 3 and 5 on the top and the right side. So put dots on each vertex. Those are going to be your points. So let's start here. So the first one is negative 4 and positive 4. And the next one is negative 1, negative 4. You can go in any order. And this one is 0 and 3. Okay. So the translation notation tells us to go to x minus 1 and y plus 3. So for x minus 1, the x-axis is the one that goes left and right. So if we're subtracting 1 on the x-axis, that means we go left 1. Left 1 unit. And y plus 3, the y-axis is the one that goes up and down. So if we're adding 3 on the y-axis, that means we go up 3. Left 1, up 3. Okay? So let's do that on a graph. Start with this point on our pre-image. We're going to go left 1 unit and up 3 units. Okay, so this point now is negative 5, positive 1, 2, 3, 4, 5, 6, 7. So negative 5, positive 7. Okay, next one down here. We're going to go left 1 unit, x minus 1, and y plus 3, up 3. So that's right here. So the coordinates for that are negative 2 and negative 1. Oops. I lost my pencil. I should be writing in a pencil. That's supposed to say negative 2, negative 1. Okay, and then last one, 0, 3. We're going to go left 1, up 3. And the new coordinates for that are negative 1, positive 6. Connect your dots. And that is your image. Okay. Another thing we could have done is subtracted 1 from each x value. Negative 4 subtract 1 is negative 5. Negative 1 subtract 1 is negative 2. 0 subtract 1 is negative 1. That's if you didn't have a graph. And then we would have had to do y plus 3. So you go to the y values and add 3. 4 plus 3 is 7. Negative 4 plus 3 is negative 1. 3 plus 3 is 6. So that's another way you can do it if you don't have a graph. Okay, next one. Let's draw our points. We're going to use the corners of the triangle. Okay, so the first point, well, we'll put the numbers on it. 0, go up, and right are positive, down is negative, and left is negative. Okay, so this point is -4 and -1. This point is -1 and +4. And this point is +3 and -3. Okay, let's look at our notation. It says x comma y plus 3. So if it's just x and it doesn't say x plus or minus anything, that just means there's no left or right movement. So the only movement that this translation is going to do is y plus 3. So that means it's just going to go up 3 units. Y plus 3 is up 3. So each vertex we're going to move up 3. So starting here, 1, 2, 3. Okay. So the new coordinates of that are -4 and +2. Next one, we're going to go up 3 again, 1, 2, 3, and the new coordinates for that point are -1 and +7. Okay, last one. We're going to go up 3 units, 1, 2, 3, and the new coordinates for that are +3 and 0. Connect your dots. And there's your image. So we'll label that one image. This one was the pre-image. So it moved up. This one moved also up and left. Okay, so another thing you could have done here is y plus 3. So you would have gone to all of your y values and did +3. So -1 plus 3 gives you 2. 4 plus 3 is 7. -3 plus 3 is 0. And that's how you do a translation. Okay. Now we're going to write a rule that describes these translations. So there's a few of them on here. There's a bunch of different points, and then it asks us to write the rule. So every rule is always written starting like this, just like the ones that we had up here. Okay? All translation rules are like this. Parentheses, x comma y, arrow. Parentheses, x comma y, arrow. Parentheses, x comma y, arrow, x comma y, arrow, x comma y, arrow. So we'll start with that. So let's do the first one, z to y. So from z to y, it looks like we're going left 2 units and then down 4 units. I know you can't see the grid on here, but you go left 2 and down 4. So if you go left 2, going left, that's x, and that's x minus. So left 2 is x minus 2. And then down 4, that's y, and going down is minus. So y minus 4. And that's your rule. X minus 2, y minus 4. From y to w, here's y, here's w. You go right 1, 2, 3, 4, and down 2. Right 4 and down 2. So when you go right 4, that's x, but it's x plus 4. When you go right, you add. X plus 4, and then go down 2 is y minus 2. Okay? Now from W to V, you go right 2 and up 2. Right 2, up 2. So if you go right 2, that's x plus 2. Going up 2 is y plus 2. Going down and going left, you can put subtraction signs. Going up and going right, or you can put plus signs. Okay, from z to u, so starting at z, going to u. So we're going to go 1, 2, 3, 4, 5 to the right, and down 1. So 5 right is x plus 5. Down 1 is y minus 1. Okay, from u to y, u is here, y is all the way over here. So we have to go left 1, 2, 3, 4, 5, 6, 7, left 7, so x minus 7. And then down 1, 2, 3. So down 3, so we went left 7 and down 3. Down 3 is y, subtract 3. And that's how you write the translation notation. Okay, the last question down here asks, what is an isometry? So I have a definition for you here. So as isometry is a transformation that maps every figure onto a congruent figure. So that the pre-image and image are congruent. So translations are isometries, and they are congruent to each other. The size and the shape do not change. So they are congruent. Okay, I'll leave that up there for just a second so you guys can copy that part down. Make sure you keep this in a safe place and so you don't lose it, because it's going to go in your notebook. And don't lose your notebook, Angel, if you're watching this. Hopefully you are. Okay guys, you can pause if you want to keep writing, but I'm going to go, so see you Monday.